Hello everyone, welcome back to GTC classes. So dear students, as you all know, we are again here with a new lecture for the Pharma 360 degree. So dear, this Target Pharma 360 degree is a MCQ series that is actually important for the all India pharmacist and DI preparations, as well as for the GPAT, NIPER, all the pharmacist examinations or all the pharmacy examinations that are actually happening here. So this can be important for the MRB, RRB, Telangana, UPSC, DI, AIIMS, all the courses. So let's have the questions, and in today's we are having organic chemistry, and the topic for today's will be going to be substitution reactions. So let's get to see the questions that are actually from the topic substitution reaction. So with the first question we are having here is the reaction that is CH3 का whole thrice. C, bromine, when reacted with H2O, we are going to have a phenol, alcohol. So we are having this bromine group is actually getting substituted by this OH with this involvement of H2O. So this is actually a SN1 reaction, since we are having this CH3 C positive formation after the removal of the Br minus. So this is the cations, that is carbocation, that is a tertiary carbocation, the most stable carbocation, one of the most stable carbocation that we are going to have. And after the attack of this H2O, we will be getting this tertiary alcohol formation. Tertiary alcohol formation. So this is actually elimination, substitution, free radical or displacement. So this can be a displacement reaction as well, that displacement, but in like we are having a substitution reaction here given. So we will be preferring the substitution as the whole. So we will be having substitution reaction. We can name it as substitution reaction. Now, which of the following is a meta-directing group? So which is a meta-directing group? Meta-directing group means the group that actually directs the newer incoming electrophile in a benzene ring at the third or fifth position. So the meta-directing groups, you can simply write down like all those groups that is having a minus M effect, minus R effect. So this NHCH3, like this nitrogen is having lone pair, so this will be a plus M group, and this will be directing the incoming group at the ortho and para positions. This fluorine, yes, the fluorine is actually a deactivating group, like it is the halogen, and the halogens having an exceptional property like their minus I is more dominating over their plus M. So yes, they are actually having net electron deficiency inside the benzene ring, but yet they are ortho-para directing. Yet they are ortho-para directing. NH2 again with the lone pair, they are having plus M nature. They are a plus M nature. But this CF3, due to minus hyperconjugation, negative hyperconjugation, it will be having minus M effect and electron deficiency at orthopara, making the newer electrophile to be only attacked by the meta positions. So yes, this CF3 is a meta-directing group. This is a meta-directing group. Okay, meta-directing group. So this CF3 falls under the category of meta-directing, that is a minus M group. So you can simply write it down. Identify the compound which is more reactive towards electrophilic aromatic substitution. So which is more reactive towards electrophilic aromatic substitution reactions? Benzene, toluene, CN, cyanobenzene, or you can see here is aniline. All those groups that are actually increasing the electron density inside the benzene ring can be termed as they are having a higher electron density inside the ring, so they are having higher affinity for electrophile to be binded. So yes, benzene is having a higher reactivity for the electrophilic substitution reaction. This methyl, due to hyperconjugation plus hyperconjugation, can be having a higher electron density at ortho-para position. This NH2, due to plus M, is strongest ortho-para directing group. It will be having higher electron density on the ortho and para position, while this CN is having minus M. You are asked which will be having the more reactivity towards electrophilic substitution. So this will having the least reactivity. This will be having least reactivity for electrophile, while this aniline, this NH2 will be having the highest reactivity for the electrophilic aromatic substitution reaction. So C will be the correct answer here. NH2, OH, these all are having the strong plus M nature groups. Williamson synthesis, a method for preparation of ether, involves the mechanism of Williamson synthesis, that is actually a ether synthesis, and in this reaction we are having a alkoxide ion, sodium alkoxide, when reacted with a alkyl halide group in the presence of dry ether, in the presence of acetone, what we are going to have is, this is actually attacking to the R, making the Cl2 move from here. So we are getting ROR, this, and this is known as ether. This follows SN2 mechanism. So this is actually a attacking nucleophile on the alkyl halide. So we are having SN2 substitution reactions. SN2 substitution reaction, that is having a Walden inversion as well, since SN2 are having Walden inversions. So yes, SN2 substitution reaction will be only happening on the Williamson's ether synthesis reaction, where the attacking nucleophile is none other than your sodium alkoxide. The most common type of reaction in aromatic compound is Now, if we are having an aromatic compound, it means like we are majority of the time we are talking about the benzene ring. So the benzene ring is actually having a high electron density due to presence of these 3 pi bonds. You can simply write down the hybrid structure as we are having a ring formation inside the benzene. All the carbons are having partial double bond character. They are actually having a higher electron density due to the partial double bond characters. And now, the majority of the time, this benzene will be having a electrophilic attack on it. Since we are having already a nucleophilic center on the benzene due to 3 pi bonds, high electron density center of benzene is already. So this will be having the reactions elimination no, addition no. We will be having substitution kind of reactions, and in the substitution we will be having a electrophile is more attacking towards this benzene for substitution reaction. So electrophilic aromatic substitution reactions are the reactions that are seen inside the benzene, or you can say aromatic compounds in majority of the times. Like nitration, sulfonation, halogenation, Friedel-Crafts alkylation, Friedel-Crafts acylation, all these reactions are under the category of, falls under the category of electrophilic aromatic substitution reaction. And as soon as the electrophilic you can say like as soon as the substituents that are actually attached on the benzene ring, they are having plus M nature, they are having electron density increasing nature in the ring, they can have the stronger affinity for this kind of reactions. Consider the following reaction. We are having 1-bromo-butene with reaction with NaOH. What is the following statement true? It undergoes only SN2 reaction. It undergoes SN1 and forms one product. It undergoes SN1 reaction and forms 2 product. It undergoes neither SN2 nor SN1. Okay. So here this make the statement wrong, and here this make the statement wrong. Now these only can be have the probable answers. Like we are having 1-bromo-2-butene. 1-bromo like CH3Br. This is our 1-bromo-2-butene. Like after the removal of the bromine, we will be getting this positive charge here. And since we know, yes, it is having a resonance with this alternate double bond. So there is a condition like bromine attack, this your OH attacks here and makes a product that looks like something this CH2OH, CH double bond, CH, CH2, that is butene, butene, 1-ol, and suppose we are having a resonance conjugation of this positive charge, making it having CH2 double bond, CH, CH positive, CH3, and now the OH attacks here and gives a product that looks something this. So yes, it can undergoes SN1 reaction and forms 2 product, one here and one here. Okay, so we are having 2 kind of products formation. So it undergoes SN1 and forms 2 products. So C can be your preferred answer. The best answer, that is C. That is C, due to resonance possibility. Which of the following gives a correct rank order from fastest to slowest of the relative rates in SN2 reactions of methyl bromide, tertiary butyl bromide, isopropyl bromide, and ethyl bromide? SN2 reactions are like you can say favored by less steric hindrance. In methyl bromide, we do not have any carbon. That is actually, you can say that it is having just methyl bromide. There is no any 1 degree, 2 degree, 3 degree kind of carbons, no extra carbons. That makes it very less sterically hindered. Then tertiary butyl bromide will be having tertiary 3 degree carbon. That is, you can say like, no, here we are having just SN1 possible, no SN2 possible. So it will be having the least one. And methyl will be having the, methyl bromide will be having the fastest one, followed by isopropyl and ethyl. Ethyl will be having 1 degree carbon. This is having 2 degree carbon. This is having 3 degree carbon. So methyl followed will be having the fastest SN2 reaction. Wrong, wrong. Methyl here, then ethyl, ethyl, okay. Then isopropyl due to 2 degree, isopropyl tertiary butyl, okay, this is also wrong. So A can only be your correct answer. Less steric hindrance, more SN2 formation, more chances for the SN2 reactions, okay, more chances for the SN2 reactions. So methyl, ethyl, isopropyl, then only tertiary butyl, then only tertiary butyl. Identify intermediate formed in the substitution reaction. We are having NH2 chloro H, again we are reacting with NH2 to form making a amino group on the benzene ring. So this is a reaction in which we are going to see a benzene intermediate. We are going to see a benzene intermediate. This NH2 will actually making this hydrogen, making way for this H plus to be attacked by NH2 minus. So the electrons get shifted here and this Cl is actually moved by having Cl minus. So we are getting a benzene intermediate. Benzene intermediate, and now this benzene intermediate is again attacked by the NH2 to give you aniline. So this will be having a cyclohexane 1,3,5 and 5-ine. Cyclohexa 1,3-diene 4-ine, no, 5-ine, 1,3-diene 5-ine, okay, 1,4, 1,5 wrong. So cyclohexa 1,3-diene and 5 will be having ine. So yes, B is the right answer. B will be your right answer, and this is also known as benzene. Benzene, and it's an intermediate. It's a kind of intermediate. Following groups exert any one of the effect on the electrophilic aromatic substitution reactions. What kind of effect are these groups going to have? We are having lone pair here. This is also having lone pair. This is also having lone pair. This lone pair is actually conjugating with the C double bond O group. So there is a cross conjugation present here. It means we have to put it in a single group. Weakly activating, no, weakly, they are not weakly, they can't be deactivating groups. Strongly activating, no, they are not strongly activating. They can be put it under moderately activating groups. They can be put under the moderately activating group. So you can write down as C your right answer. C could be your right answer here. Okay, so C is the right answer. Moving ahead, in the next question we are having identify the correct descending order of strength of nucleophilic solvents from the given below options. So we are having few options given here and we are asked about the nucleophilic solvents strength. Now, nucleophilic solvent strength, what is a nucleophile? Nucleophiles are the compounds that are actually having the tendency to donate electron pairs, and this tendency to donate electron pairs will be more when they are having actually increased by their substituting or the groups that are actually present directly attached with that particular species. Now, this trifluoroethyl alcohol, you can simply write down what are the options. So first of all, we are having trifluoroethyl alcohol, methanol, formic acid and acetic acid. I guess these four options are present in all and every of the options. So if we have to arrange, let's suppose we are having CH3OH, the fastest and the best nucleophile. Why? Carboxylic will be having resonance stability, so their ability to donate, their nucleophilic nature can be have slightly lower. So first of all, we will be having methanol followed by acetic acid. Why? Acetic is having actually one of their plus I groups directly attached. So this followed by HCOOH, that is formic acid, and now then followed by trifluoro CF3OH, trifluoro alcohol. So this will be the order. Look for the order. We are having wrong. So methanol here, then formic, no, it will be acetic. So yes, D will be your right answer. Okay, so it was trifluoroethyl alcohol. So CF3CH2OH, you can write down. Okay, so D will be the right answer. Okay. Identify the functional group from below mentioned options that leads to weakening of benzoic acid. So the acidity of benzoic acid is actually due to better stability of this benzoate ion, formation of the benzoate ion. Better the stable benzoate ion there is, more will be its acidic strength, acidic character. And we know very well, like acidity is directly proportional to minus M group and inversely proportional to plus M group. As soon as the plus M groups increases, they actually tends to have higher electron density over that particular benzoate ion with respect to the minus M group. This minus M group will be having the lowered electron density on that benzoate ion, making it more stable anion. So OH is a plus M group, NH2 is also a plus M group, NO2 minus M, Cl is having minus I, strong minus I. So yes, that is also having a stabilizing, this is also stabilizing the anionic formation, while this OH and NH2 are actually having destabilizing effect on the benzoate ion. So this A and C leads to the weakening of the benzoic acid. So A and C that are actually present on the option number B. So yes, that will be the correct. Option. Which of the following groups stabilizes a carbocation in electrophilic aromatic substitution reaction? So all those groups that are actually having the higher electron donating capacities, in simple you can also write down, all those groups that are actually having plus M nature, they are having stabilizing effects on the electrophilic aromatic substitution reactions due to their electron donating capacities, electron donating tendencies inside that particular benzene ring. This Cn is a minus M group, this SO3 is also a minus M group. So they are only having a deactivating effect on the benzene ring, making them electron deficient and less reactive towards the electrophilic aromatic substitution reactions. This carboxylic and CHO will be also having minus M nature, making it less reactive for the electrophilic substitution reaction. Nitrogen due to plus and NO2 minus M nature, while this NH2 and OH both are plus M groups, making orthopara more prone for the electrophilic substitution reactions. So C will be the right answer. C will be the correct answer. C is correct answer. Jourdain inversion or complete reversal of stereochemistry occurs in one of the following substitution reactions. So Jourdain inversion, that is actually present on the SN2 reactions. This is the property of SN2 reaction, where suppose we are having this iodine here, H and H. Suppose we are having a OH minus that attacks to this carbon, making the newly formed structure that looks like something this. So there is a complete inversion, complete reversal of stereochemistry. Like this OH can only attack this carbon from the back side, since this is a single step reaction, and in one step that leaving group have to leave and your incoming nucleophile attacking that particular carbon. There is no any intermediate formation. This is proceeded by transition state. So yes, we are having SN2 reaction, and this phenomena is known as Jourdain inversion. So this is the correct for SN2 reaction, that is nucleophilic substitution by molecular reactions. Select the correct order of orthopara directing abilities of the functional groups from those given below, strongest to weakest. We are having orthopara directing abilities. So always we are having like a negative charge, like O minus, N minus, all those structures that are actually having like CH2 minus. If it is having a negative charge, that are having strongest tendency to donate inside that particular benzene ring, the electron density is increased by the benzene ring, making them more and more electron rich. Next come is the lone pairs. Now the lone pair, if present on the less electronegative atom like nitrogens, sulfur, they are having better plus M nature groups. Now suppose we are having nitrogens here also nitrogen, benzyl. Okay, so this will be the least one. Okay, this is having just, no, that is not having that particular strongest groups, so they are weakest one. And now in NHCOR and NHR, we are having this NHCOR will be having a cross conjugation. If it is present of cross conjugation, that lone pair is actually involved in the resonance with the C double bond O group as well. So this is actually involved in the cross conjugation rather than the benzene ring. Okay, so they are also having the moderate activation. So strongest will be of NHR. Okay, and no NHCOR, no NHCOR, no. we are having NHR, then NHCOR, then only C6H5 and then iodine. So yes, D will be your right answer. D can be the correct answer. D can be the right answer. In SN2 reaction mechanism, the product obtained from optically active halides shows. SN2 reaction, we are having complete racemization. No, racemization occurs in SN1 reaction. Partial racemization, not at all. Retention, no. Complete inversion. For SN2, there is always a complete inversion in configuration. So D, D option is only correct for the SN2 reaction, complete inversion in configuration. Which of the following is a false statement for SN1 reaction? Follows first order kinetics, that is true. Absence of racemization. Racemization is present, so this is wrong. This is false. Absence of racemization is false. Rearrangement, yes, due to formation of carbocation, rearrangements are possible. Yes, 3 degree, then 2 degree, then 1 degree, due to 3 degree better carbocation stability, then 2 degree, then 1 degree. So only this is a false statement, and yes, that is been asked in your question. B will be your false statement, and that is asked in your question. The positively polarized carbon atom of a carbonyl group acts as the positively polarized carbon atom. Negative, positive. This is what a carbonyl carbon looks like. It is actually having electron deficiency, so it will be acting as an electrophile. If it is acting as an electrophile, you can also write down as it is a Lewis acid. Lewis acid due to electron pair acceptance property. So it is an electrophile but not a Lewis base. It's not a nucleophile, it's not a nucleophile, it's an electrophile and Lewis acid, yes. D is your right answer. D will be your right answer. So yes, 17 will be having D answer. Okay, D as the right answer. Which of the following is a free radical substitution reaction? Here this we are having Cn minus attack on the carbonyl carbon. So this is a nucleophilic addition reaction. Nucleophilic addition reaction. We are having CH2Cl, that is basically replaced by NO2. So this is a substitution reaction. Substitution reaction, and that is not a you can say this is not a kind of free radical mechanism. Benzene ring is reacted by CH3Cl, making it toluene. So this is a electrophilic aromatic substitution reaction. We are having CH3, toluene reacts with CH2, making it CH2Cl, yes. So this is a halogenation of alkane, and halogenation of alkane can only be done under the free radical substitution mechanisms. So yes, this is having free radical substitution. D will be your right answer. D is the right answer. Which of the following steps are involved in the given structures of a free radical substitution reaction? We are having CH3 is reacted by a Cl dot, making it CH3 dot. So one radical attacks and formation of the other radical is seen. So this is a kind of propagation step. One radical attacks to the formation of newer radical is seen. So this is not Cl2, it will be actually having HCl. One of the H dot reacts with Cl dot to make a HCl molecule, and we are getting CH3 dot. So this is a propagation step. This is a propagation step. One radical reacts with a non-radical species and making a radical and a non-radical species. That is only and only possible in the chain propagation step. Chain propagation step. Which of the following alkyl halide will undergo SN1 reaction most readily? Most readily SN1 reaction. So SN1, all of them are having same alkyl group, but we are having fluorine, chlorine, bromine, iodine. We know very well, like better the leaving group, more faster the reaction can occur here. So better leaving group among all fluorine, chlorine, bromine, iodine, due to largest bond length between carbon iodine bond, this will be having the fastest SN1 reaction, fastest leaving group iodine. So yes, D is the right answer. D will be the right answer. Better leaving group, due to better leaving group nature of iodine, this will be your right answer. So this is all about today's lecture. The 20 question we have seen from the topic substitution reaction, and this is all about today's class. See you soon again with some new questions in some new topics. Thank you so much everyone. Thank you all.